I'm Andres Campero. I'm in MIT. I'm about to start my second year. So what is it about Unreality that makes it so compelling? We dream, we watch Game of Thrones, we play that we are soldiers when we are kids. This is particularly interesting because most of machine learning algorithms are trained and do inference based only on error, on feed to the data. So a neural network updates its parameters based on whether it's able to predict the current batch of data, but also a Markov chain Monte Carlo algorithm uses likelihood of how likely is it that this data comes from this program. Children and humans use many other sources of abstract principles to guide their thinking and their learning. So think of how you solve a mathematical problem. Without yet knowing if you got the right answer, you know that you will not try calculus on a discrete domain, and you will not try a number theory theorem on a continuous domain. Same with a narrative. It doesn't have to be truth. So truth is not the only source of information, but it has to be good. It has to be consistent with some other abstract properties that you have. Right now, I'm working on an idea in a very narrow version of this. So there's a paper that came out this year in which they trained an algorithm to play Super Mario with what they call curiosity. So instead of getting any rewards from the environment, they have a forward model. So say you are in a current state and you say, okay, if I'm to take this action, what's going to be the future state? So you predict the future state, and then you take the action and you see the true future state, and then you compare, was I able to predict the future state? If I am, it means I have a good model of the world. If I'm not, then I'm curious and I want to act more and take that action. And then that generates a reward, and then train it with that. And then on the lines of thinking of consistency, I was saying, in their paper they have an inverse model, which is just like, if this is the current state and this is the future state, what's the action that led from this state to this future state? They only use it to train a neural network to generate a smart representation of the state. But I was thinking, what if instead of, that requires a lot of acting. Every time you imagine an action, you have to act it and then compare it with your prediction. What if instead of that, you train both models to be consistent? So you take the current state and you just imagine an action and you say, okay, my model is predicting this future state. What if I now take my other model and I say, if this is the current state and this was the imagined future state, what action would have led that? And then you can see the imagined action against the predicted action from the other model, and you can train them to be consistent. Hopefully, if one model learns some perspective of the same phenomena that the other didn't, they could help each other. If you think later, like a similar setting but with many models where you can train all of them to be consistent, first of all, it could reduce the number of data required, as when you imagine an action, you do not have to act. And second of all, I feel it could be a form of reasoning, not necessarily neural networks, but in this training for consistency of different models. Thank you.